wild type versus mutant heparan N-Sulfatase. Hope Thompson for Dr. J. Matthews, BCH, 4024, Biochemistry at FSCJ. First, we will talk about the wild type of heparan N-Sulfatase. And here we will talk about the active site, we will talk about the reaction that it undergoes, along with one of the major pathways that it is part of. So heparan N-Sulfatase is a sulfatase, and sulfatases are a major class, one of 6 in fact, of hydrolases. And these are commonly found in the body, and they catalyze the hydrolysis of ester sulfate bonds. They also break down large sterically hindered sugars from the body. So in layman's terms, that just means that they're very cluttered. They're closely compacted together. Now the structure, they are made primarily of alpha helices along with single polypeptide chains. And you can see that in a second. It weighs 118,607.66 AMU. Here you can see that it is a dimer. It is 28% helical, 17% beta sheets, and it has 1,020 amino acids in its residues in its sequence. So here you can see one half of the dimer. Here you can see the other half of the dimer. Here we have some of the residues off to the side. The little green dots you can see in a second will be, this one is the active site. And then we'll see some more about this in a few minutes. So the active site of heparan N-Sulfatase, we all know that an active site is where a substrate binds so that a chemical reaction can take place. Now this happens for heparan N-Sulfatase. The active site is made or written out in the sequence CXPSR. It's a sequence motif, and it happens between the 69th and 75th amino acids. Now C is for cysteine, X can be any amino acid that happens to be there, P is for proline, S is for serine, and the R is for arginine. So for the active site to be turned on, a post-translational change has to occur to that very first cysteine. And that cysteine turns into a formal glycine. Without this happening, the active site will not work, and even if heparan N-Sulfatate comes in, it will not change. So here's a picture of the active site. You can see the carbons, you can see nitrogens, hydrogens. Here's a sulfate in the middle, sulfur. You see the alpha helices and the single polypeptide chains. So the reaction starts with N-sulfa-D-glucosamine, and a sulfate comes off due to hydrolysis. So here is your N-sulfa-D-glucosamine. Here is the water for the hydrolysis to occur. And then we end up with a D-glucosamine and a sulfate. Now here you can see the sulfate is attached to the amine group. And then here you can see the sulfate is by itself, and this amine group is now fully saturated. Thermodynamics. So we all love this topic. The reaction is exergonic, and the reaction occurs quite quickly. Now there is a 6-step mechanism that goes along with the formation of the heparan N-Sulfatase. And in this reaction, an activated complex is spontaneously formed. However, as you can see on this reaction progress chart, that when the activated complex is formed, it takes energy. And this is because the covalent bonds are being formed. And when bonds are being formed, it takes energy. So even though when you have the substrate and the enzyme and it goes down to make the complex, it still does happen pretty quickly to go over the transition state and to make to the product. This is because it takes kinetic energy, and we have that. It's such a common pathway that there's enough kinetic energy to where it can get up and over this transition state quite quickly. And it happens spontaneously. Therefore, it also has a negative delta G. So more about the pathway of heparan N-Sulfatase. Heparan sulfate degradation pathway is the main pathway that this enzyme occurs in. Now there are 3 reactions within this pathway. The first one is a lyase. The second reaction is a hydrolase, and the third is the sulfatase. The last reaction in the pathway is the one that we will want to talk about, although we will talk about the buildup of the N-sulfa-D-glucosamine due to the first and second reactions when we talk about the mutation. So with the mutation, we will talk about where it happens, why it happens, and what happens when the mutation occurs. But first, we will talk about the genetics of heparan N-sulfatase. So this mutation occurs on the 17th chromosome, and it's known as mucopolysaccharidosis 3A. However, it is more commonly called Sanfilippo syndrome. There are 4 other syndromes, but this is the one that deals with heparan N-sulfatase, so we'll only talk about this one. Now, the side effects for this mutation are mental retardation, along with the buildup of sugars around vital organs. As you'll see in a little bit, when the pathway stops at the 3rd reaction and can no longer go, we have a buildup of sulfate or of sugars, and they have to go somewhere. No different than the trash man forgetting to pick up your trash. You're not going to not make any trash all week just because he forgot. You'll just have more of it, and then more and more is getting piled up. So that's what's happening. Due to this, there is no cure for mucopolysaccharidosis, although there is a clinical trial called ABO 101. They are currently in phase 2 with very good results. And because of the mental retardation and the buildup of sugar and the no cure, the life expectancy of someone with mucopolysaccharidosis is about 16, although I have read that people who can turn 17 and 18, though it doesn't happen very often. So more on the active site. So the mutation occurs on an arginine, and we found that, well, researchers found, I read their article, that these researchers found that there's 5 primary arginines that happen in this active site once a post-translation change happens to the cysteine. So first the cysteine has to change. After that, there are the 5 arginines, and what happens is the researchers found that if they change the arginine on one of the 5, primarily the 5th arginine, with a glutamine, that the pathway just continued to roll. It didn't stop it, it didn't affect it, nothing happened. Then they found that if they did the 2nd and 4th arginine within the pathway, or within the active site, the pathway had a 60% decrease in activity. So only 40% of the time when a heparan sulfate was coming in was it actually being changed. And then when they did the 1st and the 3rd arginine, there was only a 3.3% active rate. So that's not very good. So that's where the mutation comes from. So when these arginines don't work, or they're switched out, or there's no post-translational change, these things all can affect the heparan N-sulfatase. Now the pathway, we talked about this before. So the buildup of heparan N-sulfate. This is a problem. I mean, if heparan N-sulfatase can no longer work, the active site has not been turned on, we're going to get a buildup of that. But the rest of the pathway will continue. We talked about the lyase, and we talked about the hydrolase. These 2 things will continue to pump out their products from the reactants. Like, it's not going to stop. So because of this, you build up all of this heparan N-sulfate. Now, there's no inhibitors. We have talked about inhibitors in class, and there's no inhibitors to stop this pathway from continuing even when we don't have anything to change it. Here's the reaction again. We did say this. So the N-sulfa-D-glucosamine, even if water is added and the active site is not on, we can't do anything. So there is no D-glucosamine and there's no sulfate being made. So with all this being said, if there's no post-translational change, if there is, if the arginines are mutated, one of them or 2 of them, it can make a difference. Of course, there's that 1 in 5 chance that it doesn't make a difference, but it can make a difference. Heparan N-sulfatase is very important for us in breaking down these sugars and breaking down what we need it to, so that we don't have a buildup around our organs. And so if this reaction can't occur, And this 6-step mechanism cannot occur and the active site cannot turn on. It's not very good. I mean, you won't make it. None of us would be alive to make these presentations. So just keep that in mind. So like I said, I had heparan and sulfatase, and my name is Hope Thompson, and have a good one.